Hey guys, welcome to devops school. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
So if you look at this here, some of the commands which I am having right now, how do we monitor this container? So if you want to monitor the containers log, so you can use the command called log. Let me tell you here, logs command will fetch you the logs when it says container, basically not exactly everything which is running inside a container, but actually it will give you the logs of PID1. So any executable which is running with the PID1, that logs you can see that here. For example, let's see there's a Ubuntu. So Docker logs, see there's nothing, okay. But if you run something Docker exec and container ID, it will get clear, I guess. ls, it get clear, that's the problem. Yeah, so here it will show you the PID1. So this is the one thing. I think Jenkins will be much better example for this. So here you see here Jenkins, you want to see the logs of maintaining Docker logs. Here it is. So this is the way you can see the logs. So now you want to see the logs of MySQL container. So here Docker logs, and you see this is the input of that shell script which is running a MySQL container. So that is the thing. So yes, you can see the logs of container, basically PID1 through logs command. PS command you have used it already, so you know that. Now what is the stats command? So here stats command will tell you CPU, RAM, network and IO utilization. You see that. So you can check it out, this each container, and then how much CPU they are utilizing it right now, memory usage, you can look at it, and then see the limit also. So when you look at the limit, that means I have only 2 GB RAM, so my utilization is maximum, it can be 2 GB. So they take the limitation from the host machine. Can you set the limit? Yes, you can set the limit for the container. So while running itself, you have to set the memory and CPU, and you can try Docker help run. I think you might have tried in the before lunch. So that way you can set the
Docker update.
Yeah. So memory and all. Now network IO input output also you can get that information. So nothing great, it's just a statistics. If you want the individual container information, just pass the parameter. Okay, then here it is, and all this information, same information about the individual container you have. Now that's the stats, that's the infra monitoring, basically we can say. So see log monitoring, process monitoring, infra monitoring. Now how do we know that, let's say here there's a multiple container is running right now, 4 container. how do we know which container is holding a which process ID in my host machine? That is important. Host machine, see here. So 4 container, 1, 2, 3, 4. So how do we know which is holding which PID? So simple, if you really want to know that one for the process monitoring in the host machine, so Docker top and container ID, and this is your process ID on the host machine, PID 5062 and PPID is 5046, which is the host machine PID. Okay. See here, 5046, here it is. Okay, so this is the way. So this is a handy information if you really want to monitor. So stop will give you those stuff. Now next command is event. What is the event? So here event will help you to monitor the Docker daemon. Docker daemon, are we having some wrong commands which is passing to the Docker daemon, or right command which is passing to daemon? So how do we decide on that? So you can write a Docker daemon. So for example, Docker daemon, right now it's having nothing. If you open up a new console, CentOS sudo -s and then CentOS events, so Docker events. And do you want to do some creation of containers? So run -itd ubuntu. Okay, so I created a new container. See here. So if you run this command here, event, it has sent this command, then network and started. Okay, so I said right, run will be create plus start, which is here, and they give you the network also. Okay, and stuff like that. So this is how it happens. This is how it happens. So yeah, event command, you can monitor the Docker daemon. So yeah, these are the commands which is important for you to monitor the containers in your environment, and that's all. Any questions on the monitoring commands?
No, Rajesh.
No.
All right.
Now next topic is image. So for that I need little bit of help from my slides, because I don't feel writing too much. So lunch, after lunch is energy is little bit less. So let's use this slide to explain you the images. Okay, so now the question is, what is image? So we have completed that learning playing with the containers. Now we have to use the image. What is image? So let's have a little bit of recap of what we did last day, and I explained, I spent a lot of time actually for this, so I hope you remember. So if I go now day 1, and here I said image, which is basically mounted to the container users image. So now the question is, what is this image? So image is a root file system plus user file system plus application file system. Here also something similar, I explained it to you. Here now, what is a root file system? You know that you can see it, that root file system, and I have explained your root file system, boot file system, user file system, application file system. So now you know that. So this all package, one package is being called as a image. So understand that this is a file system. This is a file system. Okay. So let's get started. Now here, did I talk about something else also? No, that's okay. So now the question is, what is image? So by now, based on your understanding, whatever we have built, image is collection of file system, right now, file systems, such as you have a root file system, on top of that user file system, on top of that application file system, plus application file system, plus application file system, plus application file system. So here if I see, if you want to understand that correlation, here it can be Ubuntu or CentOS. Then it can be Ubuntu runs with Ubuntu, right? CentOS run with the CentOS. Applications, let's say, what do you want? Let's say Java. Java, here you have. After that, here you have a Tomcat file system. See here, Tomcat. And here you have a Tomcat. Then your applications one, V1. Then application V1.1 patch, major release, minor release. So this is something is your image actually. This is called image. This is called image. This is called image. Are you able to understand this? Right? Yes. Everyone. So with that context in mind, let's little bit spend time with slides also. So what is image? So image is made up of a file system. I told you, and which is basically layered over each other. Okay, these are the file systems, and it's on top of each other, layered over each other. That is the reason we don't call it file system, but we call it layer. Okay, so see here, you have a layer 0 is a one file system, layer 1 is another file system, layer 2 is another file system. So image has a multiple file system layered over each other. Each file system we call it layer. Understand that each file system we call it layer. That is how it is, each file system. Now if you look at this here, all this layered coming together is called image. So image, you may have a, understand that image you may have a one layer also, and image you may have a 3 layers also. So like, look at this here, from the layer 0 also you can create image, then from layer 0 plus 1 also you can create image, and from layer 0 plus 1 plus 2 also you can create image. So from these 3 layers I can basically create a 3 image. So when I create a image 0, that will have a content only layer 0. When I create a image 1, will have a content of layer 0 and 1. When I create an image 2, will have a content of layer 0 plus 1 and plus 2. So that way, the conceptually the image is a collections of file system, and each file system we call it layered because of this are file system layered over each other. Okay, and start with the 0, 1, 2, 3, something like that. So are you getting the conceptually what is this image?
Yes.
Okay, good. Now the changes of the file system may vary, depends on what you are keeping it. Bottom layer will be always a root file system, not a boot file system. So you should not tell it's operating system. Container is not at all operating system. Container is not at all virtual machines, because virtual machines and operating system has a boot file system. But here you won't have a boot file system. You have a root file system. And then on top of that you have a changes, like in this image you have nginx, and then layer 2, which is a top image, a top layer, which you have updates of ubuntu. Okay, so you can change the root file system and logic will be same. So from multiple layers forming together and create a one image, and that same image, understand that same image shared with a multiple container. Same image is shared with a multiple container. So I'll put it in a simple way. See here, you people wants to access my laptop, but with your own user ID. See here, so I will create an account for all of you in my laptop. So all of you, when you log in, you all see desktop, you all see my downloads, you all see documents, this, that, and all. But none of these are always shared. How come? The answer is hidden here. You can find the answer here. All of you see the desktop. How come? All of you see my desktop, my download. All of you see my documents. But if you store some file on that view, other people cannot see it from your desktop. So how can this isolation is getting created? Because of mount and namespace. So in a Windows also, if you look at this, Windows of Microsoft has created a one image. Okay, and in image they put it up everything like a desktop, my download, my document, my photos, this, that, and all. So whenever you create any account as such, that account the view get mapped to your user space, something similar concept. So here also, if you look at this, sorry, so here also, if you look at this, the same image shared by the multiple container, same image shared by multiple container. Okay, so here you have Ubuntu layer 1, layer 2. Okay, are you understanding this, what I'm trying to say?
Yes, Rajesh, go ahead.
Yeah. Now you see here, each layer, guys, how do you identify layer? That's a question. How do you identify layer? So basically each layer you will get one UUID. UUID means it's a UID created by SHA-256 algorithm. It's a 40 character universally unique ID, and that way you can identify the layer. Okay, very simple. So that way you can identify the layer, each file system. So now the question is, when image has a multiple layer, and when you create a container from the images, so that how this merges, how this different file system, basically the layers is being merged together, because in the container you see the only one file system, so has to be merged multiple file system, right? So these are the rules which get applied on the runtime whenever you create any container from the images. So these are the merging rules get applied. Let's understand this. So when there is a conflict, higher layer always win when there is a conflict in layer. What is the meaning of it? Let's understand the through image. Okay, so here there is a one layer which is you have here, and okay, let me create a little bit bigger. There's a one layer which is here, there's another layer which is here, and there's another layer which is here. Okay, so you have a 1, 2, 3 layer. Now this form is one image. Okay, now from this image, if you create a container, then containers will have a single view. So how the merging happens? So understand the scenario. Let's say opt location, there is one file called raj.txt. Okay, let's keep it Raj only. Opt here also there is a file called Raj. See, both these are the file system. This is the file system, this is the file system. So two location you have a same file, but the content of this is here I love Docker. Here the content is I love Kubernetes. Okay, so this is the content of the file. So if you create the image out of it and you create a container out of it, so what you will see inside a container, what you see, because the content is I love Docker and I love Kubernetes. So what you will see,
I love Docker because the latest version layer will take always priority.
so that is the rule actually. Yeah, so in this case higher layer always win when there is a conflict, because here it was a conflict. You have a file here also, both the layers you have a same files and different content. In that case Docker says take the latest one which was committed later, that means with the layer which got created on top of it, so take that. Okay, so that's the logic. Now the question is, you must be wondering who's doing all this stuff, who's maintaining the layers, anatomy of the layers, merging the layer, making sure that it's looks like a flat file system, who's doing it? So all this has been done by union mount. Okay, all this is done by union mount. So image layering is accomplished through union mount. Now union mount is available in the Windows also and in a Linux also. So union mounts means union of mounts, simple. So this is done through union mounts. So union mount, what exactly it will do? Union mount allows to mount, understand that. Union mount allows to mount multiple file system, because multiple layers over top of each other, but combining all of the layers single view. So application think, operating system thinks, or you think it is like a symbol giving the application OS single regular everyday file system. So all this is magic which has been done by union mounts. Okay, make sense?
Yeah, Rajesh.
Yeah, now next question is, all our layers are read only except top layer. Yes, this is a good thing. So let's understand. So if you think, see here, there's a one layer, two layer, three layer. Now from this you created a one container. So the container get one layer, and this is a read and writable, but this is a read only. You cannot modify this. Once it's commit, see, you cannot change this layer. You cannot. Yes, you can modify the layer, and from that you can create a new layer, or you can delete the layer, but you cannot change the layer. Understand that. It's a read only, read only. That means once if it is committed, either you don't want delete it, but you cannot change the same thing again. Okay, so it's a read only. But container layers is writable, because each time when you create a container, it create a one writable layer, and that is where we are writing the files. So now you know that the diff command, how it works. Diff command will give you the files which is only from this layer. Make sense so far?
Yes.
Yes.
So you see that this here, there is a three layers. We created one container which is writable layer. All these three layers is locked, has a UUID, has a different file system, and running on the boot file system, which is your operating system kernel. So yes, you have to read more about boot file system, root file system, and many other union mounts and many other things, one by one. So overall, this is the
Yeah,
information.
just one doubt.
Yeah.
Yeah, who creates a layer? Like if I create one file, a layer will be created?
No. Layers you create, actually, you create a container, right? Remember?
Yeah.
So whenever you create a container, you get a one writable layer. See here, last statement, please read it. Every containers get its own writable top layer, which is the red one. So that layer is a writable. You can, whatever you write is being written in that. So that layer, the moment you commit, it become a new read only layer.
Okay.
Okay, so here you see there were 4 layers: locked, read only, that's a part of the images, and the container is sharing all this layer with the help of union mounts, and this is the anatomy of image.
Rajesh,
Okay.
Hello Rajesh.
Yeah.
When you say commit, when you commit it, what does that mean?
Commit means commit. That means the changes which I made in the writable layers, I want to make it permanent. I want to
Okay.
share with someone else. It's like
So
this.
whoever
In
is
Git,
running the container can do it?
yes, anyone
Okay,
can
so
do
when,
that.
okay, so supposing I commit something, after that, whenever I try to write anything else, it will be another layer again.
Yes. You have to create a
Okay,
container from the new image which you committed.
all right.
I'll
Good.
show you the second. I know that you will be having confusion, but I'll just clear all this stuff. Just give me a little bit more time. Okay, guys. So now let's have a little bit of discussion, because without discussion I don't feel satisfied. I mean, notepad discussion.
I have one more doubt. Is it when I build an image, then a layer is made, or when I start a container, then when is it that a layer is made? When I build an image or when I start a container?
So, okay, I'll hold this question for time. Okay. Okay, so now let me give you a little bit of perspective which is not there in the slides. So understand this. There's a guy who's called Union Mount. Okay. In this, it's a special guy. Okay. Please read a little bit about Union Mounts, what exactly it can do with it. So now what happens? See here. How many layers you have in this? 1, 2, 3. Let's put it up this one, root file system, because root file system has a default user also, remember? So a root file system and application file system, then here you have all these things. So all together five layers is there. So this is creating one image. Now the question is, what is image? Actually, image is just a notion, just a tag, just a label, just a human friendly keyword. Okay, understand that image is for us, because if I tell you, you take layer 0, take layer 2, take layer 3, or if I tell you, take the layer ID, which is, you see that here, 87026 dab 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 40 character there. If I tell you that, you get crazy. But if I tell you, okay, take the Jenkins image, you immediately understood, oh, Jenkins image, I'll have a Jenkins. Take a Ubuntu image, take a MySQL image, take a Tomcat image, take Apache image. So anything, if I tell you the name of it, so then you recollect. It's you work, you function, we are the human being. So image basically is a representation for not for system, for human. Okay. So what image will represent? Image represents last layer. Okay, last layer committed. Okay, last layer committed. So here, let's say I committed this one last layer. So I might have committed this one on top of this one. This one got committed on top of this one. So this one got committed on top of this one, and this one got committed on top of this one. So this is a root file system. We call it a base file system. Base file system. This is, we call it a base file system. Okay. So here the parent of this layer is this one. Parent of this layer is this one. Parent of this layer is this one, like this. So when you call the kid, automatically the parents will come. You know that. Okay. So that is what is happened. So image is a representation of last layer committed. So when you say, look at this here, when we say create a container from this image, okay, container from this image, so this will take this, then this will take this, this will take this, this will take this, this will take this. Now you have so many layers, so all this thing will be merged together and create one writable layer. Yes, who's merging it? Union mount. So let me write it down. So here all a layer, and rules I told you, if there's a conflict, all layers of the image is merged and create writable layer. This writable layer, is your container.
Please enroll for our channel membership 399 plan to get access of all the parts.
Now let's understand that. Day one, I've been telling you, see here, go to that. When we say container, container has a user space which come from the user namespace, get mounted from the image. So how this, if it's not mounted, then how you will feel it's operating system. So it get mounted. All this thing here, you get it mounted. So this is the image. Now this writable layer is divided into two parts broadly. I'm not confusing the too many topics at a time. So broadly divided into the two parts. A location which is called diff, and there is a called merged. Okay, and this get okay, you can see it, you can see inside a container, the container. Okay, this you can see inside the container, and diff will have only one file, would have only those files, delta files, which you made it after that running the container. Okay, so this is something which I have for the discussion, and this is the image. Now probably if I prove it, you will have a better understanding on this. So I can go ahead and show you the demo for this. Any questions so far? Any questions so far?
No question from my side.
Guys, are you there? Yeah, go ahead.
Say when you're helping us to understand what an image actually is. So let's say I have a tomcat with me. Okay, and I'm trying to create an image out of it. So like, I have my own setup details, pertain to the Tomcat which I use. I want to make an image out of it. So it's like all the file system that's related to that would be considered as, the application file system, what you have explained in the like in the notepad, that with root file system would totally form an image, and that could be used in some other container. That's what you're trying to explain, right?
Right. See, when you want to create an image of Tomcat, then remember Tomcat need a Java.
Yes.
Java need a root file system. Root file system need boot file system. So boot file system you have it at the host level. So here you have a root file system. Ubuntu, Fedora, these are the flavor of root file system. So so you have a root file system. On top of that install Java, commit, then Tomcat, commit, then application, commit, like this. So I'll show you during the demo now, so you'll understand better.
Okay.
Any questions? Other one? Okay, so now let's prove it. What is image? So look at this. So here what I'm doing. So guys, I have so many containers. So let me clean up all of it. There's so many containers. Docker containers. Okay, so I'm stopping all the container in one go. Removing all the containers in one go. And deleting all the images in one go. See here, all the images. So guys, clean everything, clean within 3 seconds. See, no container, no image. Now the question is where the layers is being stored. Layers, okay, where the layer is being stored. So it's stored in the var lib docker under overlay 2. So how do I know it's overlay 2? Docker info, my whatever is the storage driver, your layer will be stored at that place only. So if it is a device mapper, you'll be having device mapper here, overlay 2, whatever it is, other ones also. Okay, so here overlay 2. Now what is the size of this? 0 bytes. Now can I delete can I pull manually one image? One image, let's say I'm pulling the Ubuntu. See, it's pulling the layers, downloading the layer, pull complete, extraction complete. Now CLS. So how many layers do you have in the Ubuntu image? How many layers? 4. So now that means I got to know 4. I want to know how many commit has happened on this image. So Docker history and Ubuntu. See here, total, these are the 4 layers you have it. This is writing 72 point this data MB and some bytes also last layer. So these are the number of layers you have in the Ubuntu image. Now you want to see that here the first layer, which is 72 MB. So if I do du hyphen sh hyphen max depth is equal to 1. See here, 76, which is the from the top second one, correct? So this is the layer which you have, which is the base layer which I showed you here. Okay, so now can I go inside it? Can I go inside the diff? Layers file system will be in a diff. Understand that. Have you seen this one anywhere? This stuff? Have you seen this?
Yes.
So this is your root file system. Okay. Now if you go back a little bit of it, if you go to another one, you will see some changes which is done on top of it. See, some var, only var changes has been done. Something might have done. So this is the layers. Go back. Okay, go back. I said the moment you create container, you get a one in writable layer, correct? I said very clearly, the moment you create a container from this image, you get a one writable layer, and writable layers which has a merged all the layers into that writable layers. Okay, one more thing here I said, the writable layers will divide it into two parts, diff and merged. Okay, so now let's create one container. So Docker.
How can we find which one is a higher layer?
So here Docker history, and this is the one Ubuntu. Okay, and here inspect Ubuntu, and remember Ubuntu inspect command you can use for the containers also and image also. And here these are the layers, and out of this you see here upper work directory merge, and the little bit of understanding you have to make it. This is how. Okay, see here. Okay, and these are the layers. Okay, the numbers you might not see exactly. Okay, understand that. So I'm just helping you to understand anatomy. Anatomy means how basically this scaled it out, but SHA creates the multiple ways to connect the dots. So this is SHA-256 algorithm. So if you really want to know everything, you want to deep dive into SHA-256, then you can read offline hours and then get into that. Okay, so here you have 4 layers to that image, and you can connect like which are the upper layer and stuff like that. Okay, so this is the one. Inspect the images, you will see everything. So here we got to know every layers you can inspect also, by the way. So lots of things, but I'm not talking too much because my topic is on that one. So here I said the moment you create a one container, then one new layer will be created, that will be writable layer. Okay, so here Docker run -itd Ubuntu, you know this command very well, and you see here, look at this layer got created. Now its name is same, but this is for initialization for memory, so just ignore that init one. It's hardly 8 KB, but if you see that second one, which is a merge layer of everything, see 77 MB, which has merged everything together. So if you create one more container, one more layer will be created. Okay, so here this is a writable container, a writable layer, which is for the containers. If you see a Docker PS, see here FO is a container ID, and your container for this layer ID is this one, A81. So if you inspect this Docker, inspect container ID, and you see A81. See here. See here. Okay, A81. For that particular container, your layers which is you have mapped out, which is this one. Okay, so this is the things. So now you see, can I go inside that? And here, this is the merge. How do you know this is the mounted? This is the mounted to the container. I said very clearly, this get mounted in the containers. You will see this one only. So this is the df-kh. Look at this. Look at this here. Okay. So this one get mounted. Okay. Can I stop this container? Docker stop. And see if I check the mount, gone. So this merge layer, see here, merge layer is gone. Container is still there. Merge layer will get disappeared. Again, if I start this container, see here, came. So this, that's what I was telling you. All the layers of the image, the moment you start the container, it get mounted. First day only I told you. It get mounted to the container, and this is the merge layer, merge location. Any changes, whatever you did in the container, will be still saved inside this directory. I did not do any changes so far in the container. It's not, it will not be there. It will be empty. Let's check it out. CD diff, see it's empty. Now can I do some changes in the container? See here, Docker execute and touch opt rajesh1.txt. okay, see the rajesh1.txt. Can I come back? I'm inside this directory. Can I find the rajesh1.txt? See, look at this very carefully. Even though if I delete that, even though if I stop the container, my changes will be there inside this. But what happens when you start the container? They merge all the writable layers and the metadata of the delta of the container and put it in the merge location. So if you again you modify something else, if you do something here, look at this. I add one more file, Rajesh2, and see here. See here. So it's so beautifully planned by the SHA-256 algorithm, and this is the one. So guys, this is what I wanted to tell you here. So all layers of the image merge in and create a writable layers. This writable layers is your container. Writable layers is your converted into diff and merged. Now which one you have to merge actually? Which one you have to commit? What do you think? You need to commit and create a new layer of this or this. Tell me.
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devops.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.